Great, wonderful to see. Just as Harindra comes up, I just mentioned that that business of sharing allele frequencies between populations is one of the simplest things we can do to improve health for many people around the world. It's very, very straightforward, very powerful, and it would be wonderful if we had more allele frequencies being shared outside of European populations. The most of the data sets are deep in Europe, but not deep outside. Okay, Harindra.
Thanks, Ivan. Let me find the slides. Oh, there we go. Hi, everybody. My name is Harindra. I work at the Broad Institute, and I co-lead the Discovery workstream. And I'm going to give a quick overview of 5 minutes of the Search API product itself, and then hand it over to Kyle, Nara, and Tony to talk about concrete implementations. The reality is, personally, when I hear the word standard, my eyes glaze over. Sorry, Ivan. But what absolutely excites me, and work through vacations and weekends, is what you can do with it. And that's what Nara and Kyle and Tony are going to talk about. So this is a quick overview. And as Mark Fume and I were designing the Discovery workstream, we wanted one statement to describe what we wanted to do. We wanted all of our products or different things to solve some challenge. And all of them had to fit into this worldview, which is basically how do you build a network and then ask meaningful questions from it. And we knew we couldn't solve this challenge with one standard, and we shouldn't. That would have given us like a monster of a standard. What we could do was build separate different products that address different parts of it. So the first challenge, or the first standard we were working on, was driven by the Matchmaking Exchange. They wanted a way to ask a question from a network of computers. For example, the group of, if each one of you were a server, I'll ask you a question. Hey, do you guys have a patient with these criteria? And then you'd answer me back in a standard way. Now, the next part is, what is a typical question? Now, here we fill back to the Matchmaking Exchange and also some driver projects like Illumina to say, okay, what are the typical questions a clinician or researcher would want to ask this network? For example, you would ask a question like, do you have a variant at this position? And the answer would be something like a set of patients who have that variant but have different phenotypes. You might want to narrow down your search further by saying this variant and these phenotypes, for example, microcephaly, and so forth. And you want to add knowledge onto it, such as nonsense homozygous. Now, how do you build a question that is flexible enough and extensible enough to address these questions and any others that come in the future? Now, most of the first thing you do when you have such a big challenge is you build a team. And we were very fortunate to have a pretty big resource of folks working with us. And a lot of them were from the Matchmaking Exchange, who were part of the original specifications, and all of us knew the problems that the Matchmaking Exchange had in terms of building its standard. And we wanted our new standard to address all of this and be flexible enough to grow. The timeline, we took roughly about a year. Starting from the design phase, we talked to everybody in the world saying, hey, what are the questions you want to ask, in what context? And then we made a draft using Prio art. And then we had this renaissance where we had a lot of different ways of doing it. And finally, we came to a consensus on a version 1. And then it was a race to get implementations ready and have a first global federated network using test data, because we didn't want to start out with real data. We wanted 1,000 genomes to make sure the standard was strong. So I won't go too much into details, and I actually hate putting JSON or code in a slide, but just to get across that this is how it looks like in reality, where the machines talk to each other. Conceptually, you could think of this as a set of Lego blocks. Each Lego block is a part of a question, could be a gene, could be a variant, could be a knowledge. And each one of these, like for example, the circle one, that's how the computer sees it, is a small JSON object, and we define it with JSON schema. The idea is over time, these components will get elaborate and rich, and each of our implementers will add it back to us. Now, this is another innovation we came up with, is how do you make a system that's flexible, and how do you how do you get in these new components and not have this propagation of useless components? So the way we did it was we only make a component if it's used in a real world project. For example, case log, variant matcher, and Cafe Variome, and RD Connect who joined our network. They are the ones who will make these components because they need them. And then we will have them in a component store. And down the road, what we'll have is a system where the GA4GH will approve each one of these components so that you'll have a set of components which are approved. You might have other components which are not approved, but if you feel like taking a risk, go for it. So forth. So innovation, think the iPhone or the Apple platform. So enough about the overview and the beauty of the architecture. The important stuff is not the standard itself, but what you can do with it. So the test network we built is between Johns Hopkins, Illumina, RD Connect, and Cafe Variome. The idea was we would join these machines together and allow you ask a question from one of them, and through that, it's a federated network. You could ask the rest of the other folks the same question. So I started out with Kyle.
Thank you very much, Harindra.
Yep.
Hi, I'm Kyle Farr. I'm a clinician. My specialty is rare disease, and I'm also a principal investigator at Illumina. Our product is called Caselog, and what it is a search engine for genomics. So basically, the question that I think clinicians are trying to answer is, I have a variant that causes disease that I don't know what it does, but I want to know, does it cause disease based on information from cases and cohorts worldwide? And we'd love to be able to answer that question, but the reality is right now, genomic data is largely locked into silos. People find it very difficult to share private genomic data. So it's very difficult for physicians to kind of get an answer to this question, I think as Heidi pointed to in her last talk. So what we've done is work with the GA4GH standard to allow these kinds of federated queries to work across different nodes. And in this way, it allows you to search into other people's silos, get the answer to your question, and aggregate the results, and get a result as if you had access to all the world's data together. So we've tried to make this as simple as possible. So at the very top, you can see our interface. It's literally a Google search box, or Illumina search box in this case. And your clinician just simply enters your variant or gene of interest. When you hit search, then the magic happens. So first it does a local query of that variant against your local database, and it asks, is there an association between my variant and any phenotypes present in people who have the variant in my database? But it not only does that, but it also does the same query to other federated nodes across the network. So those can be other Illumina Caselog nodes, or they can also be nodes representing Cafe Variome, RD Connect, or Variant Matcher. The bottom line, though, is that each one of these does its own association and p-value calculations separately, and then the results are all aggregated back to the source. And then you do a meta-analysis at the source, so it's as if you had access to all the data. But actually, you never were permitted access into the private genomic data of each instance. So I'll just give a demo right here. This is what our interface looks like. And you enter a variant of interest. This is a particular variant which is known to be recurrently de novo mutated in patients with congenital heart disease. And what this actually does is it goes across Australia, as well as instances in the US, and it gathers together all the data of how many times is this seen across all cohorts, how many times should I have expected it based on the de novo human mutation rate using a trinucleotide adjusted model adjusted for multiple hypothesis testing, and it gives you a final p-value at the end of whether this variant is actually associated with disease and with what diseases. We've actually shown that you can also use this to discover new disease genes automatically. So we brought together two collaborators, one with a cohort of about 200 patients with childhood neurodevelopmental disorders, another large cohort of over 4,000. And we actually identified a new disease gene, CHD3. It's actually not significant in either cohort by itself, but when you bring them together and do that meta-analysis, it now pops up to 10 to -8, which is genome-wide significant. And this is just one of many disease genes that we are now able to discover in this way. So finally, I just wanted to sort of put everyone eyes on a goal here. I think This is very exciting, the work that our collaborators, and I need to thank them right here, for putting together sort of the first network of this. But I really think that there's a huge amount of work that needs to be done. If you think about the amount of sample size and cohorts that are needed to actually identify most human disease genes, I think for rare disease, we probably have fewer than half the disease genes known, maybe much less than that. For common disease, we probably need a cohort size at least 10 times that. So there's no question that no one is going to have enough data in their individual silo to answer these questions and really spur the discovery that's needed. We really all need to work together, and we're very excited to work together with GA4GH to do this. Thank you.
Okay, second tool in this network is Cafevarium. In this slide, I'd ask you to basically ignore the graphics. They're just to stress that what we're building is a federated network with centralized components, networks, subnetworks, and lots of various functionality, the sort of thing Ewan mentioned at the start today. The main point of this slide is the headline. We are, over the next few years, going to build essentially a rare disease data ecosystem across Europe for both data discovery and patient matchmaking. It will do more than that, of course. It will handle data sharing and analysis, but given the search API focus of this talk, I'm concentrating on those aspects of this ecosystem. How are we going to do that? Well, basically, we've acquired funding. Here's a project that started in 2018, 15 million. And next year, we scale that up with a 55 million euro project called European Joint Project for Rare Disease. These projects involve the European structured consortia called European Reference Networks for Rare Disease. There's 24 of them. 4 of them are in the first project that started now. All 24 will be in the project next year. The project next year that starts will also cover rare disease biobanks, patient registries, and so on. And the idea is to create a discovery and matchmaking system across all of this. The tooling, a tooling that I've built over more than 10 years now of developing discovery approaches is called Cafevarium, and I'll present that now, but there will be other tools in this system as well. Cafevarium has been used in various rare disease settings already over a few years, but also in black at the bottom there are lots of other context. Healthcare data, not least, large amounts of healthcare data. We'll extend that via HDI UK, and Andrew Morris will tell you more about that this afternoon. Biobank samples, the stratified medicine project, so on. And some big pharma projects as well, looking at toxicity data. So we know the tool can do the job. This is the tool in a graphic format. We don't have time to go into the details. I'll throw up the functionality here, but the point is it is a fully functional data patient discovery platform. You can either grab a photo of that or look at the slides later if you want to see the details. This then is the snapshot static demo, if you can call it that, just showing how, as well as all the inbuilt API functionality in the system, we've now added functionality to support this search API that we've developed between us in the group. This is a demonstration of that in use on the test data set, federating across both the data in our site and across Variant Matcher, but we're also federating to the others as well. The tool, this particular interface then allows you up the top there to query for any number of variants and any number of phenotypes. And here you can create, as you see, each of those items gets a letter assigned to it. You can add and remove those to get more or less of these entities. You then enter here a Boolean logic, so you can assemble these guys in any way you wish, and then you run the query and the responses come back as a count. We can also deliver data, we can also deliver IDs, we can also deliver links to go and request the data and so on. So all of that is in the system already. So the top part of this text here I've basically said we've implemented. We provided from our Cafevarium system, I think that had a big influence on the design of the search API. And we are now undergoing an effort with BBMRI and the biobanking industry to ensure interoperability with those guys as well. Obviously, there's lots of things this will allow to be done in terms of rare disease utility. I guess they're self-explanatory, and to save time, I'll leave it at that. Thank you.
I will talk about the last one. So our tool is Variant Matcher, and this tool was created as part of the Baylor Hopkins Center for Mendelian Genomics. We are one of 4 NIH-funded centers for Mendelian Genomics. And as part of this project, we have created a database that is a phenotypic and genotypic database for our project that's called PhenoDB. And as of now, PhenoDB stores the phenotype data and the genomic data on more than 8,000 individuals. So we are always trying to find ways to share these data, of course, taking consideration our consenting and IRB limitations. But the first way we found to share our data with the other projects around the world was GeneMatcher. GeneMatcher was created basically mainly to deal with sharing data at the gene name level. And as of today, it has almost 6,000 users in 77 countries. And we have had, I think, about 100 papers citing matches that happened through GeneMatcher and allowed the discovery of novel disease genes. So to go further on sharing our data from the Baylor Hopkins Center for Mendelian Genomics, we decided to create Variant Matcher to now focus more on the variant level. So it's more or less trying to follow the same idea of GeneMatcher, but it's a little different. And some of the difference I listed here on these bullets. So we will require that the user that is registering to Variant Matcher to be actually approved by the site administrators. We will only allow 10 coordinates to be queried per user per day. We are not making the entire exome file available for the queries. We are focusing on the rare, less than 1% in the NOMAD, Exact, or the public databases, and on the single nucleotide variants and coding variants. So these are the variants that we are making available to the queries of all the patients, individuals that have been sequenced in the project, affected and unaffected. And following the idea of GeneMatcher, both parties will be notified of any match simultaneously. So the person who is coming from outside and querying our database will be informed about the findings, but the user in the Baylor Hopkins Center for Mendelian Genomics will also be informed about the person who is coming to the database and querying about this variant. And they will receive emails about the notification that will have their email contact, the same way as GeneMatcher works, and then they can go on and make more, exchange more information about this variant, the phenotypes, and set up a collaboration if they think that this is worth it. So another thing that's different from GeneMatcher is the queries will not be stored. So if you come and you query one time, you will have to come in 6 months and query again if you want to know about the new data that has been put in the database in this time. We are not storing the data as we do in GeneMatcher. So we decided that we would implement the API as we are part of API version 1. I don't know if this is the version 2, if completely different, but we also wanted to participate on that. So we are now connected to Café Varium, to CaseLog, and also to RD Connect. And hopefully this exchange will be happening soon, but it's working in the backside. So we can now, the users can query our database, and from here they can also query this other database and get a more complete information about their variant and where they find it and what the phenotypes of the patients associated to these variants are, and try to find out if their variant is pathogenic or not. This is just a screenshot of the information that the user will get with the variant, the information about the other user, who the user is, and where's the center, and what's the email contact, so they can go on and exchange more information. Oops. So I think this is all. Thank you.